Okay, here's a next example. One of the things about this example is this represents the first circuit ever that I'm going to need a state machine to do this. So I was reading this problem last night, and essentially what this problem is a 5-bit counter. So I actually modified this to say you can use no more than a 4-bit counter in your design. So essentially, it's going to be a 4-bit counter with some extra control on this. And the control is going to be provided by a state machine. So let's do this thing. We can draw this. We can draw a picture of the high-level diagram circuit. It's going to be a counts up. It has a 4-bit output, which is count, and it has an LED that blinks. So let's put an LED there, and I think that's it. I need a clock, and I don't think I have any other inputs on this. Okay, so as is, it looks good, but once again, it'd be very easy to do with a 5-bit counter, but I'm clamped to using a 4-bit counter. So I'm going to draw my 4-bit counter. I know it's always counting up, and so what I'm interested in, certainly a count. It's a 4-bit count value, and it does have a clock, and I'm going to need to control this thing. The important signals on this is it has an RCO, and what I do with the RCO is the important thing. So I'm going to feed the RCO outwards, and this is a status output, which means it's going to be the input of a state machine. And so RCO, okay, and the output of this thing is going to be LED. Okay, looking good here. Now notice that I could have connected a signal like this down RCO, but typically I got out of the habit of connecting control signals. I just name them. It's understood that the status output is going to be an input to the state machine, so I don't need to connect it. Only thing I do need on this thing is a clock. I'm just going to put a little triangle there for my clock, so I don't need to draw that thing. Okay, so this thing, what's going to happen here? It's going to count up to 15. The RCO is going to turn on. That's going to be my signal to essentially toggle the LED. So this is going to be a two-state machine. LED on, LED off. Two-state machine, because that's all the LEDs doing. Sometimes it's on, sometimes it's off. Okay, so these values here are labels to help humans understand the state machine without putting too much effort into it. The interesting thing here is the output. And what I'm going to do here is put that LED inside here. This is an output. LED on. There's no overbar over it, so that means the LED's on. In this state, I'm going to put an overbar, which indicates the LED is off. Okay, so the idea here is this thing is counting, it's doing its thing until it gets an RCO. And RCO is going to cause it to go to the next state. But in the meantime, that RCO or the counter here hasn't reached its terminal count, so I'm going to stay in that state. I only want to change states when that counter transitions or hits its terminal count, and then I want to toggle the LED, which I've done here. So this state is very similar. I'm going to stay in that state so long as I don't have an RCO, and when I get an RCO, I'm going to transition back to the other state, which essentially toggles LED. So transitioning from one of these states to the next state, not the self loop, essentially toggles the LED on this. And I'm going to call this problem done. Once again here, we'll go over it real fast here. RCO is the status output of the counter. Not counter, we'll put an R in there. That means the state machine is going to read that status and typically send out control signals. But this particular problem doesn't need a control signal. Just needed to blink that LED, which I have there. Okay, folks, I can't think of anything else to say about this one, so we will call it done.